Good afternoon. We are BearTooth Energy Services, and thank you for joining our presentation on the development of our North Dakota sections of interest. We are confident that our progressive plan will most efficiently bring the greatest financial return to our clients. Now I'll introduce our geology expert Nawaf to discuss the lithology of the area.
Thanks, Kyle. The Williston Basin is our basin of interest, and our fields of interest are Alger and Stanley fields, which are located in the central west of the basin. Our formations of interest are the Bakken Formation and the Three Forks. The upper and the lower shale members are organic rich source rocks that supplied oil to the middle member, which is the reservoir rock. During the transition from Devonian to the Mississippian period, major uplift and erosion occurred along the margins of the basin. I'll pass it off to Kyle.
Thank you, Nawaf. Our area of interest is in the northwestern corner of North Dakota. It is a 10-section, 6,400-acre location and is 16.5 miles northeast of the Missouri River. There are 14 horizontal wells currently drilled there. Our task requires analysis of these and other wells in the area for data such as porosity, permeability, and thickness of geologic formations. The purpose of gathering this data is to determine the amount of oil in our reservoir. We interpret information from well files to find statistical averages and to perform the original oil in place calculation. Once all the data has been processed and summarized, we determine that our reservoir contains approximately 57.7 million barrels of oil. We then create our reservoir model, inputting cross-sectional depths to simulate the structure of the geologic formation. Through trial and error, we determine the optimal number of new wells to maximize production of the reservoir is 14 wells in a stacked wine rack configuration. Finally, we conclude that the performance of our simulation model matches past production history of this area. This means our model will predict future oil recovery with a high degree of certainty. The architecture of the simulation model translates to an additional 52 new wells in our area of interest. These will be facilitated through 5 new well pads, resulting in a total of 66 wells available for production. Now I'll turn it over to Rob to discuss the drilling portion of the project.
Thank you, Kyle. The 14 current wells in the field were all drilled as unconventional horizontal lateral wells. The 52 infill wells planned out for this field will be drilled in similar fashion. The wells will be drilled on 14 well and 5 well pads. Drilling will commence in 4 sections. The first section to be drilled is the conductor section, which will be dug out to 80 feet with a rat hole machine, making a 20-inch hole set with 16-inch casing. The 13.5-inch surface section of the well will be drilled to 2,300 feet measured depth with a spud rig, and 9 5/8-inch casing will be set in the hole. An 8 3/4-inch hole will be drilled to 10,075 feet measured depth for the intermediate section of the well with the primary drilling rig, and will encompass the remaining vertical section of the well as well as the curve to build the lateral to horizontal. This section will be set with 7-inch casing. The final section of the well is the 6-inch horizontal lateral production hole, which will be drilled with a primary drilling rig to a total measured depth of 18,700 feet. This section will be set with 4.5-inch production liner. Now Nawaf will talk about stimulation.
Thanks, Rob. We'll be using slick water as our fracking fluid. We'll have a total fluid of 126,000 pounds per stage. Ottawa sand will be used as the proppant type, and we have a total of proppant volume of 184,000 pounds per stage. We have a treating pressure of 8,200 psi. Moving to perforation, we'll have 40 stages to perforate. Plug and perf method will be used, and 3 clusters per stage and 60 degrees facing. I'll pass it off to Seamus.
Thanks, Nawaf. The production outlook for this field is great. We expect this field to have a total production of 20.5 million barrels of oil equivalent over the next 20 years. Now I'm going to pass it on to Nady, and she's going to talk about artificial lift and surface facilities.
Thank you, Seamus. I will talk about the artificial lift part. In your field, artificial lift will be applied in each well to change our production rate. The Rotaflex long-stroke pump unit was chosen to handle the entire production. This pump has a plunger size of 2.25 inches, stroke per minute of 4.6, and a maximum depth of 11,000 feet. This is our surface facility layout for the 14 wells. The separator is responsible to separate oil, gas, and water. Then the oil moved to a heater so that the paraffins will be melted. Or gas will be sent to a gas pipeline so that it will be ready to be sold. Or a wanted gas will be sent to a flare so that it will be burned. Or water will be stored to a tank and after that it will be disposed by truck. Or oil will be also be stored in a tank so that it will be ready to be sold. Now I'll pass it over to Seamus.
Thank you, Needy. Economics is the most important part of any project as it all comes down to if the project is making money or not. To determine this, we came up with different price scenarios, calculated all the capital costs, then I ran an economic evaluation to determine the value of our field. As the picture showed on the last slide, oil prices are impossible to predict. We came up with 4 price scenarios, then ran a risk analysis and came up with a probability for each scenario. Our most probable scenario has oil prices at $60 per barrel and $2.60 per MMBTU for gas. The capital costs were split into 4 categories: drilling costs, completion costs, artificial lift costs, and surface facilities costs. The total cost per well is about $6.2 million. This results in the total field development costing $329 million. Finally, an economic evaluation was ran. To do this, a net present value for each price scenario was determined. Then, a weighted average of the scenario outcomes was calculated using the probabilities that were determined for each scenario. We can conservatively say that our field is worth $317 million over the next 20 years. It is good to note this is all profits, as the expenses have been accounted for. We would like to thank you for your time. We hope you enjoyed our presentation.